Okay, ladies and gentlemen, let's go ahead and begin taking a look at continuing by integration by parts. In this case, we have integration of x to the fourth e to the x dx. Now, we could still do the same thing. We need a u, we need a dv. All right, well, u could be either one of these. The problem with making u e to the x is every time I differentiate it, I get e to the x. Well, that doesn't really help me a ton. But at the same time, if I were to attempt to set dv equal to e to the x dx, every time I integrated that, I would get v equals e to the x plus c. So e to the x isn't going to go away for us regardless of where I put it or how I put it. So let's figure out something that would go away. Well, if u equals x to the fourth, when I differentiate, du equals 4x cubed. Now, that's fine and dandy, except for the fact that I still have x cubed. Well, I guess we'll just have to take it because it's the best we can do at this point. So we say u equals x to the fourth, dv equals e to the x dx. So we've done that. Now, from there, I'm going to find v equals e to the x plus c. Doesn't really change, doesn't really help, but it also didn't make it worse. Now, if I were to do simply uv minus integration of v du. Now, folks, if you can't start to remember this by now, you're going to be up a creek because we're going to use it over and over and over again. Now, so it's u times v, and that stays the same, u times v, x to the fourth, e to the x minus the integration, so minus going backwards, the integration of v du. So it's going to be 4x cubed e to the x dx. You say, great, except I can't do anything more with that. So now that I have done all this work, I now go from basically what amounts to step 1 to now I have to do it all again in step 2. All right, fine. What's u? U equals x cubed, or 4x cubed if you so choose. We'll do that. And dv equals e to the x dx. So du equals 12x squared. V equals e to the x plus c. So here I go again, plus and minus as we go back. So I end up with x to the fourth, e to the x, minus big O brackets, 4x cubed e to the x, minus the integration of 12x squared e to the x, and then eventually I'm going to put a plus c down here. Now, you'll notice that it's minus out in front of big O parentheses because it's minus this entire quantity. When I take this quantity over here to integrate, I'm still going to have to take this negative and distribute it. So what ends up happening is I have the positive first term, or in reality it stays whatever sign it is. This will switch signs, which in this case makes it negative. This negative and this negative will make it positive. And now I go from step 2, and you say, well, not shockingly, I still can't integrate it. I'm going to have to go to step 3. But you'll notice we begin to get a positive, negative, positive pattern going over here. And that pattern is going to be something we're going to highlight here momentarily. If I were to continue doing this, u equals 12x squared, dv equals e to the x dx. And so we get du equals 24x. dv is, or v is going to equal e to the x plus c, down and back, plus and minus x to the fourth, e to the x minus 4x cubed, e to the x, plus, now the nice thing is since it's a plus, they all stay the same. I get 12x squared e to the x minus the integral of 24x e to the x dx. All right, let's do it again. So that was step 3. Let's do step 4. And to do step 4, we say u equals 24x, dv equals e to the x, du equals 24, v equals e to the x plus c, down and back, plus and minus, x to the 4th e to the x minus 4x cubed e to the x plus 12x squared e to the x. Now because I got a minus out front, I end up with minus 24x e to the x, and minus a negative is going to be plus the integral of 24 e to the x plus c. Oh, thank goodness, finally we have it. I can finally integrate this. The integration of 24 e to the x is 24 e to the x plus c. So our final answer is as follows. But you'll notice I keep repeating the process over and over and over and over again. So there should be a way to take this large process and condense it down. And indeed there is. It's called rapid repeated integration by parts. So whereas we just did repeated integration by parts, we're going to do rapid repeated integration by parts. Integration x to the 4th e to the x dx. U equals x to the 4th, dv equals e to the x. Now the nice thing is I could integrate e to the x all day long, and it's just going to stay e to the x, e to the x, e to the x. Down here I can begin differentiating x, 4x cubed. I end up with 12x squared. I end up with 24x. 24, and in fact I can even derivate that and come up with 0. Now you'll notice that every time here we did times minus the back, times minus the back, but every time I had to go back, that became the first step of the next process. So really what I ended up doing was I ended up multiplying until I finally integrated on the last step, and that's the process we're going to do here. U times V stays the same. This U times V, but now, because of the change in sign, it's going to be a minus, that pattern of plus, minus, plus, minus. Plus, minus, plus, and finally at the end, minus. Now the nice thing about this is I can write it all out, x to the 4th e to the x minus 4x cubed e to the x plus 12x squared e to the x minus 24x e to the x plus 24 e to the x. But when I go back, it says minus the integration of 0 dx. Well, the integration of 0 is nothing but plus c. And so that's the final answer. And if you will take a look, those two final answers should match exactly. By using repeated integration by parts in a table format, we can speed up this process tremendously and get to our answer significantly sooner. The one thing you do need to be careful of is if I have a problem like the following, x to the 4th e to the 2x, when you say u and dv, u might be x to the 4th. dv, however, could be e to the x 2x. v is going to equal, when I derivate this, I end up with 1/2 e to the 2x. So you need to be careful when there's a constant connected here, and that constant can cause us significant problems. So with that, you need to watch your constants, but that's rapid repeated integration by parts.